So when we look at the data we have right now, right? So here's the data in our employee table we've been using as an example so far. Looking at that, how would I know which employee was in which department? What's missing? What could you imagine being there that would make it easy for me to see which employee was in which department? Yeah, another field or column, probably with that department code in it, right? Because that was our primary key in the department table. So if I even do a select star from department, just run that for a second here, right? We see our codes are things like ACCT and so on and so forth, right? ISYS for information systems. So we can easily imagine having a code that looked just like that in beside each employee so we could know what department that person was in. Okay? It's a basic logical concept. It occurs to most people that that would be the way, if I just was looking at employees, how would I know how they relate back to department? You'd probably carry that primary key from department over into the column. Now, of course, there'll be 2 or 3 people in the same department, quite possibly. So it's not something we would worry about uniqueness in that column. Right? For every employee in, say, information systems, we'd see the same department code beside their name. That's perfectly natural. So foreign keys, as we call that, aren't unique. We have to allow repetition in that column because otherwise it wouldn't be a one-to-many relationship, would it, right? You can't have many employees in the same department unless you allow that to happen. Okay, so that's basically what we're going to be talking about. I just wanted to introduce it as a concept that really is pretty natural for most of us to get into. So I got a slideshow here I'll just quickly run through to introduce the one-to-many relationship, right? So basically, this is how we go back to our department employee tables, and this is how we would, in our drawing syntax, actually draw that relationship. The fact that the crow's foot is on the many end, it's bigger, that's the wide mouth of the crocodile, so to speak, right? That shows that, okay, we're going from 1 on the department side over to many on the employee side. A good tip I'm going to give you right now, and I'll repeat it again later on, is whenever you're analyzing these relationships, now we're worrying about more than one entity at a time, always kind of read the relationship out loud or at least just in your head to yourself in both directions. So that crow's foot line, as we often call it, indicates that a department has many employees. Good, but always read it back the other way to make sure it makes sense that an employee is in one department. Now, if that's the case in the particular company that we're modeling here, in fact, I think it was what our Prime Medical Group or something was the name of our scenario we're working with, right? Then that is the correct model. It's a one-to-many, and we know that because an employee is in one department, but a department has many employees, right? Good tip, though, to read it both ways, because if you're in a situation where a department has many employees, but an employee could be in many departments, well, that would be a different kind of animal. It wouldn't be a one-to-many, would it? Right? We'll get to the many-to-many later on, but for now, okay, we've looked at a single entity. We've now looked at one-to-many, right? So that's kind of like, you know, to relate that to the real world. A single entity is like being single. One-to-many is polygamy, right? There's also a one-to-one relationship, but of course that would be marriage or monogamy, right? Monogamy, polygamy. That's right. You're right. You got it right. And what would a many-to-many be? An orgy. Okay. All right. So entities are very rarely isolated in the real world, right? They always are relating to other entities. Now, of course, you have to be reasonable, right? If you sit down to model, you know, Joe's plumbing, you know, business to help him manage his inventory or whatever, you don't want to include every entity that you see around, just the ones that are key or part of the business itself, right? So just like we don't list every possible attribute we can think of for a person, just the ones that are relative and important for how the business runs. So same idea there. All right, so there's a degree of occurrence between the tables, right? So one to many in this case for this kind of a relationship. Now, so that little crow's foot line there is what we call like a one-to-many relationship indicator. Technically, when we do the database modeling this way, you notice we don't actually add. We talked about adding a new field or column in the table. The strict rules of our modeling syntax say we shouldn't actually list it as a separate attribute. The only thing we show here are attributes that relate strictly to or are descriptors of the entity itself. The line itself with the crow's foot on the end, that is what tells me that there's going to be that, what we call a foreign key. Something that is coming from the department table that we're going to store over there for each record in the employee table, allowing us to relate it back, okay? So, as we just had our discussion up on the screen a minute ago, if I was doing this in Excel or something, I would see something very much like this, where our employees now have a department code column. Why not call it department code? That's what it relates back to, right? Plus, if we've been following that naming convention of the sort of the table prefix in front of the name of each field, so in the employee table, calling everything emp this, emp that, right? Not hemp this or hemp that, okay? We aren't smoking anything here. But emp this and emp that. Well, department then, why not call it department code? For one thing, it helps it to stand out. You can clearly see that it's not part of this table, right? Sure, it's a column in the table, but it helps us to understand, oh, well, that really doesn't belong. It's not a descriptor, so to speak, so much of the employee as it's what relates the employee back to DEPT, department, and the department code. Like the way it's put here, that it's really like a visitor to the table. So that's why we call it the foreign key. No, that's not my best joke. I didn't make that one up. I'm not going to take credit or blame for that one. Okay. But its sole purpose, the only reason it's there is to relate back to the department table. It doesn't have any other reason to be there, but that's why it is there. Okay. So to add that, right, we add an extra column to the child table to store the associated foreign key value. So we have to have the column there, but that's not the end of it. Systems like SQL Server, MySQL, and so on, they also enforce, potentially, as long as you do it right, what we call referential integrity. So, referential integrity means that we know that relationships between entities are being maintained properly, right? So for example, if we have a not null constraint on the foreign key, it means we can't create an employee who isn't in a department, right? Otherwise, it would break referential integrity. We'd have a child record with no way to relate it back to the parent record. Now, under some circumstances, that might be allowed, but that's the kind of rule we can enforce with a referential integrity relationship. We'll see that we'll have options such as maybe because of this relationship to maintain referential integrity, we'll actually implement what's called a cascade delete. So that if you delete a parent record, all the related child records are automatically deleted as well. So you don't have any orphan children, right, that are left behind. Okay. I know that it's a dangerous way to put it sometimes. People start thinking, oh, what's he going to do? You're going to go, if you kill the parents, you got to slaughter all the children so they don't come back and catch you later on? No, I didn't say that out loud. That wasn't recorded, was it? Oh, no. Okay. All right. So that referential integrity is a way to maintain the relationship between entities based on the relationships that are there, right? So in order to add that, so it's step one is to add the actual column. Step two is to actually add a new constraint, okay, a foreign key constraint. That way as well, one of the things we're going to get is we can't add an employee into some department that doesn't exist, right? You can't put an employee in a department that isn't there. That's another way we maintain quality control of the data in our system. Okay. So I have a script for you to download from Blackboard and run in your database. Let's just have a quick look at it. It's right here. Sample of new department employee relationship create statements. So if you download that, get it up in Mansion Studio, it looks like this. Okay, these first two commands just delete your old tables if you have them, right? So when we look at the create for department here, it's no different, okay? Our department table doesn't change in this relationship now. The parent still stays the same in the one-to-many relationship. Okay, and we can insert some values for the departments. But down here, when we create the employee table, here we have the new foreign key field, the column that we're adding, right? Notice we're specifying not null. We touched on not null in our discussions earlier, that that's a way of saying we cannot create a record with this blank, right? We have to supply information for this. Okay, that's a way to guarantee that we don't create an employee that doesn't belong to a department in this case, right? And here's our same code we used to create the primary key earlier, but here's the second thing that's new in our create table statement, necessary to maintain our referential integrity relationship. That is a new constraint called a foreign key. The foreign key relationship, basically this is just a name we give it. Okay, you can call it Fred if you want to. It's good to give it a more meaningful name than that. Okay, the foreign key, we mentioned the field or fields because it can be again on a composite, just like we've seen we can have composite primary keys. But just we'll keep our discussion simple for now. We'll say it's a foreign key field. It's one field. So we named the field. This is the field in this table that's the foreign key. So that's referring to this one right here. So the foreign key is this field, references. Okay, the next keyword is references, and for that we have to say the name of the table and the name of the field that it refers back to. And that's how we create a foreign key constraint. Right? So just to run over that again, department didn't really change. We just have our create for department like normal. So our primary key is department code. When we come to employees, so that we can relate them back and forth, we actually create the repository here, the field to store the information, and we enforce referential integrity with this additional foreign key constraint. We simply say foreign key, this field, references, back in this table, this field. And that establishes the relationship between the two. And that will satisfy that one-to-many line that we've drawn in our model. The end result is, okay, every employee will belong to a department. We can't leave it null, and it can't be a department that doesn't exist. So every employee will belong to a department, right? And that'll be our quality control that we're enforcing here. If we wanted to delete a department, we would have to move all the employees into another existing department first, and only then would we be allowed to delete the department, unless we turned on that Cascade Delete. But that just gets too bloody, and I don't want to get into that right now, right? Okay, all right. So what we can do is we can run this script. Just notice the difference here, that when we're supplying the department code as a foreign key to the employees, right? If this doesn't match an existing department, it'll raise an error. It will not be able to insert this record unless it's a valid department code for an existing department. So I'll just execute this.
Which part specifically did you execute again?
The whole thing. So just make sure nothing is selected, and just the whole thing should run. It will, first of all, drop the old versions you have of your tables, recreate them in this new arrangement with the referential integrity constraint, and then insert sample data in each. Now, just before we go on, something I should mention about that is, okay, there's a reason why these are in a certain order, right? For example, the create table statement here for employee, if I tried to execute this command and the department employee table, the department table wasn't created yet, I'd get an error, right? I'll show you that. I think it's an important point to make. I'm just going to drop both of them, so I have no tables here. Let me come down. If I try to create the employee table first, okay, see, I get a nice little error message. Foreign key references invalid table department, right? Cannot create. So the table itself was not created. I was not able to create the employee table because the department wasn't there first. I'm emphasizing this now because later on when we start getting 4, 5, 6 tables all together in a database, the order that you create them becomes important. You got to kind of work from the outside in through the relationships, because you got to have parents there first before you can create the child tables and so on. And also when it comes to inserting the data, same thing. So I can't create the employee until I make the department. So I'll come up here, I'll manually make the department. You don't have to do this, you've ran the whole thing and it's worked, so that's good. So if I make the department first, then come down and create the employee table. Now it worked, right? Mind you, I have no data yet because I didn't run any inserts yet. Let me just show you another thing that gets affected in terms of the order of operations here. If I try to insert a given employee, I'll just pick one, anyone. Okay, I get another error message. The insert statement conflicted with the foreign key constraint, la da 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 da, right? So basically, I tried to insert an employee, but I don't have any departments defined yet because there's no data in the department table. So that is an example of our referential integrity doing its job. It's working, right? We can't make an employee in a department that doesn't exist yet. Common sense when we really think about it. So once more, the solution is do things in the right order. Okay? Populate my department values, create my departments first, and now I should be able to make all my employees.
And you can do it individually as well right now?
I could do it one at a time or all of them. Yeah, it doesn't matter. There we go. So they're all in there. So let me just do a quick select star from. Okay, I'll do one for department and one for employee. By the way, you can run 2 selects. You'll just get 2 outputs, right? Okay, so the results pane shows the output of the first query that was run. So I see my 4 departments there. And then I see below it, okay, the output of the second select query. I think I ran out of room because I didn't give enough space here. Okay, I have 8 employees all added, and we can see the department codes. So I know, for example, that Cliffy Patty here is in information systems right there. So that's really, okay, what that is all about. So looking at that script then, what we reviewed is that the foreign key column, okay, we create the column itself to hold the data, but that's not enough. We have to create that referential integrity constraint, the foreign key constraint. The foreign key, this column references such and such a table, and that table's column, right? And that's how we write it. Okay. So we could do more and more examples. A player can only play for one team, but a team has many players, right? So if I was going to draw that on the board, okay, I could just draw the one box for team, another box for player, listing attributes, and then my arrow would go between the two. Which side would have the crow's foot on it? Which gets the many side between team and player?
Team would be many.
The team has many players, so the crow's foot goes on the player. That's okay. You'll get a chance to practice. I just, we only have so much time, and I want to give time for people that need help too. A nation can have many states, but of course a state can have many cities. That brings up the point that we can go sequentially down a whole chain of one-to-many relationships, right? It doesn't have to end in one generation. Think of it like a family tree almost. Only usually go from left to right instead of top to bottom, okay? So it can spread out and spread out, right? So a nation can have many states, a state could have many cities, and away you go. In fact, we have an example for you to work on for homework for Wednesday based on this exact scenario. All right. So we're going to create nation, state, and city tables in our hands-on exercise. I'm going to leave it to you as homework to do for Wednesday to try and bring your solution to class so that we can review Lab 1C as well as quickly review the solution to this. Okay? Where is that to be found? Well, right here. Going back in here, practice case. Okay? right? So here's our nation, state, and city. So we're giving you this information, right? And here's some sample data. That Canada, ID equals CA, okay, for Canada, has these two provinces. Well, we know there's more, but we're just giving a little bit of sample data to work with, right? With these values here for the name and the populations, okay? And we have another country here, US, New York, Indiana, with various cities and so on with populations. So that's our sample data to work with, right? Now, this does require introducing one new topic that I just want to wrap up with. That is an identity, okay? With an identity, how that works, I'm surprised you let me get away with this, okay? Notice in my create employee, my employee number in this case is a data type integer, right? So it's numbers. But what I've done is I've used this identity. Control Z. Okay. What identity does, it's kind of like auto number. Instead of us having to worry about supplying these unique, remember primary keys will always be unique. That's what they're there for. Instead of us supplying these unique ID values, okay, these unique employee number values for each employee, why not let the system generate it? And that's exactly what an identity does. Just so you know, there is optionally, I can go like this, and I can put two different numbers. I'll just put the default values of 1 and 1. What that does is the first digit is the seed, and the second digit is the interval. In other words, I'm going to create integers starting at 1, counting up 1 each time. You don't have to worry about that, but I decided to finish my discussion of identity, pointing out those are options. So if I wanted to start counting at 1,000, right? Maybe I'm creating a table to hold all the orders for my company, and this is going to be the order number. I don't want people to think I'm starting on order number 2. I want it to look impressive. So the first order number I want to be 2001 or something, right? Then I can just put whatever number I want for the first value here, but just be aware that it'll always count up. It'll always count up from whatever I put here as the seed number, right? Now the increment is how much it counts up each time. Pretty rare that we need to change it from going up 1, okay? But that's how the identity works. It will look in the system and see what numbers have been used so far, and by the way, it will never ever reuse an old number. Okay? So if you later on delete employees, right? So there was an employee whose employee number was 7, but they quit and they've gone and you deleted them out of the system, you'll never create a new one with the employee number 7. It'll always generate new numbers counting up. Okay? Then it never goes back and tries to reuse old ones.
Is there a limit on this way, like number-wise?
Well, the only limit is the size of an int, right? What is that, 2 million and something? So if I get more than 2 million employees in my company, okay, then I won't have to worry about buying lottery tickets anymore, will I? If I can support a payroll of that many people, then I'm, So, in practicality, there's really no limit, although physically there is a limit, right? But the real world is I'm never going to run out of numbers for the number of employees in a company. Now, mind you, if you were counting something that could be a lot bigger, like stars in the heavens or whatever, right? Then you'd probably want something bigger than simply an int, okay? If you're going to use something like an identity to count each one. But that's nice and easy for us. That way, we don't have to. And notice, down here, I didn't supply values for the employee number in my inserts. That's a difference in this from the insert commands we used the first time through, where we hard-coded numbers. We supplied 666, 777 for employee numbers, right? I don't even mention it, which is also one reason why you notice I'm using the second form of the insert, the one where I specify the columns I'm going to give values for. Since I don't have to give a value for this employee number, because it's an integer identity, it creates the numbers for me automatically, the system, then I can just leave it out. I don't even have to mention it. In fact, if I tried to, I'd get an error, right? Because you can't override the default behavior of it generating the number without raising an error unless you set a special property, which we won't get into right now. I mean, there's always a way to do everything, right? If you bend the rules the way you want. But this is how we normally would work with an integer identity, right? We don't have to even think about it anymore. And notice down here when we actually looked at the data, employee number 2, 3, 4, 5, right? So at some point I must have used 1, because remember I had a failed insert. Even though it failed, it used up the number 1. So the first one was 2. Interesting to note that, eh? So it's just generated these employee number values for me automatically. So I want to explain that syntax. So it's all explained right here, right? Integer identity, that's how you create that kind of a primary key field. And when you do your inserts, you just don't supply a value for it. You just leave it out. Don't mention it. It'll look after itself. It will generate its own values. Okay, very good. So getting back to the instructions, right? So when you create your city IDs, we'll use identity. Right? So try for Wednesday to write your create table statements and your table design charts for nation, state, and city. Okay, we'll have some time to wrap it up if you don't get it done, but as much as you're done ahead of time before Wednesday's class, the better. And then basically we'll get our create tables up and I'll have some inserts ready for you. Actually, you can write your inserts because all the data is here. Just the sample data, just use it and basically populate your tables with the information given in the instructions. Any questions about that homework assignment? Just remember, as it says, you have to create and populate tables in the right order from parent to child, right? So which one would you do very first? Nation, right? And the next, you would obviously do state, and the last city. If you try to create city first, it won't work. You got to go like the grandparents and the parents and the children and so on, grandchildren all the way down the line, right? And the same when you insert data, you have to do it in the same order because you can't create records in the child that don't have a parent to relate back to in terms of parent-child relationships. Okay, so that's basically all I really wanted to cover today. I could do a discussion of inner joins, but I think we'll leave that for Wednesday because I did say I'd come around and help people if anyone's still stuck on 1C. Okay, any questions though? Okay.